So these cutters that we were just talking about, the knives, chisels, and gouges, we call non-discriminant cutters. In other words, you grab the tool and then you push it through the material and get the cut you want. It does not refer to the surface of the material. It's guided by us as we push it through the material. And whereas these tools we're going to call discriminant cutters because they refer to the surface that we already have. So that we look at this plane, there's a kind of an infeed table here. As we enter the cut, the infeed table part of the tool is touching the material, then the blade takes its cut, whatever the setting is for shaving, and then there's some support on the outfeed table over here. So as we push the tool through the material helps to guide the tool, therefore it's discriminating. In other words, it can only take a certain amount of material per pass. It's limited by the way the blade is set and by the way the tool is shaped. So these tools are super important for building a carved instrument because they have some semblance of the shape of the instrument built into them. In other words, they're all convex, both across and along the body of the plane, or spoke shave in this case. And all of these tools have a curve in both directions, so they're called spoon bottom planes. This one is actually a spherical plane. This is one that I made here in the shop recently. We're going to talk about how these work, and we'll walk you through how a commercial tool is modified and tuned up to perform properly as a spoon bottom cutter, and how these would be good examples. These two are, or these three actually, are all commercially available that you can buy and then cut up and modify to work on the plates. Okay, these 4 cutters. And then these are tools that I've made, and we'll explore some of those things as well and show you how these get made, how they work, and the best way to sharpen and set them. We'll also, we're going to get into actually creating tools. So when I made this tool, I was able to use a spoke shave blade from Lee Valley Toolworks, I guess. And then, with a tool like this, I wanted to create my own blade for this tool because I didn't like the blade that came with it. And so I made one from tool steel, which we can buy and have hardened. Probably by a knife maker or somebody local can harden these tools for you. We're going to get into tool making and tool modification in order to support our guitar making habit. Finally, in the last group of edge tools that we're going to address are the scraper family, which are a really powerful and incredibly versatile and useful group of tools for the guitar maker. And why don't we just do a little introduction on scrapers here and show you how these work. First of all, they come in a great variety of thicknesses. These are available from Stu Mac, and these are, this one's 5 millimeters thick. This one looks like it's about 3 millimeters, or so about 1/4 inch and about 1/8 of an inch thick. So obviously these aren't bending, they're hard. And then there's a variety of other ones. This one's about 0.25 millimeters or 10 thousandths thick. This one's probably twice that thick, something like that. And so, of course, the nice thing about scrapers is that you can bend them while you're using them to both stiffen them and to reshape them to help fit the surface that you're addressing. Now, let me just show you a little bit about scrapers. So first of all, we said before that when the rake angle gets around 0, all right, this would be 0 rake here. When the rake angle gets around 0, we're calling that a scraping cut. In other words, the tool is moving in this direction, and here would be your scraping cut like this, right? So, thus the name scraper. But actually, there's more to it than that. So let's say the scraper is here. Then when we sharpen it, we turn a burr on it like this. Okay. Now we know when we have a burr like that, if we were to drag the scraper along the work at a 0 degree rake angle, nothing would happen because it would just slide on the bottom of this scraper here, and the sharp edge would not get involved. But if we tip the scraper down like this, by leaning it forward, we engage this burr. And now if we magnify that burr, and here's your work, now we see that the angle between the work and the cutter is not a scraping angle at all. This is not 0 rake. This is quite a lot of rake, okay? So now we see that this kind of thin scraper with a burr is cutting more like a plane with a chip breaker. So the wood comes up here when it's cut, and it curls around just like it were being handled by a hand plane. The chip is controlled by this curved surface and kind of rolled up. And I'm sure some of you have had that experience where your shaper, when it's sharp, will create these beautiful little curls. It's amazing, really. But then, on the other side of it, we have a 5 millimeter or 200 thousandths thick scraper like this. This scraper won't cut the same way. It's going to cut just because it's sharp on the edge. So this is a hardened tool. The edge is slightly hollow ground. In other words, when it was sharpened, the grinding wheel was square to the table that the scraper is laying on. So this edge is square but slightly hollow. And it throws a little tiny burr on both sides, but not a turned burr like this. This is a burr that's just thrown by the grinder. And this one we have to lean forward also, but this one really is kind of a negative rake or scraping cut. So when we're using this, pushing in this direction, we really have a kind of a negative rake condition on this, and it requires quite a lot of pressure to hold it in the cut. But you get a very controlled cut. It's not capable of digging in and cutting very much, even though it's a non-discriminant cutter. We're going to do this step by step, starting with the knives, going on to the discriminant cutters and the scrapers. Going to show exactly how these things are sharpened. I'm going to show you my method for removing metal and polishing the metal, which I think is really efficient and will help you spend more time cutting wood and less time sharpening. That's my hope. A tool geometry preamble wouldn't be complete without talking about skew a little bit. So skew, or you could call it a shear cut, is a very interesting and useful thing in woodworking. And let's talk about how it changes what happens while you're cutting, okay? So let's say this is my cutting edge here. So there's my sharpness angle, 25-degree sharpness angle. And let's say that represents the blade in here. So we have some clearance, right? We have some clearance. And then this is the rake angle, which we'll measure and set here. So we have, so there's our rake angle. And that's our rake angle when we're pushing the tool straight, right? But if we push the tool in this direction, but we change the angle of the tool like that, so that we're now pushing the tool in this direction. When we look at the rake angle, we see that it's way different, okay? So we have a huge difference. Remember before it was here, right? And as we rotate it this way, it gets bigger and bigger, or lower and lower. In other words, it's more slicing and easier to penetrate. Not always what you want, depends on the material. But it's important to understand that that's what happens. The same thing, it's a little bit harder for me to show you with this gouge, but the same thing happens with the clearance. The clearance angle also gets larger. There's more clearance as you rotate the plane this way. Another thing that happens is, let's say, here's the width of your cut. So your plane iron is this wide, we'll call that X, right? And so now when we do this, we can see we don't have as wide a cut. So that means that the same cutter is doing less work, but it has the same number of molecules on the edge. So each molecule is seeing a lower load and lower heat. It's not working as hard. And I think almost anyone who has ever used a hand plane has discovered that, gee, sometimes when you push it at an angle, it works better. Or sometimes it doesn't. Sometimes you don't want more rake. Sometimes you want less, depending on the material. But at any rate, I just thought I'd point that out, that you have the benefit, I mean the change, not necessarily a benefit, but the change of not only the angle, but also this reduction in width that lets the blade last a little bit longer, and it behaves as if it were sharper, in other words, because it's cutting less material with the same edge in the same condition. So one of those things where there's two things conspiring potentially in your favor. So when I say it doesn't always help, for difficult woods, usually you, like say figured woods, curly maple, woods that turn around or want to tear out, usually you want less slicing and more scraping. And if you look into plane design, you'll see that the bed angle of the planes is variable depending on what it is you're trying to do, what kind of material you're working with. Anyway, it's all part of the fun of understanding tool geometry and trying to get the best tool for your application. Again, so that you can enjoy the work, do it efficiently, and join the long line of musical instrument makers stretching back thousands of years.